Okay, welcome back. Let's do another problem here. I want to solve for C in E equals mc squared. And this is actually a relationship between mass and energy, mass and energy that Albert Einstein popularized. This is actually what happens for objects at rest. When things move, then you have to add extra stuff in. But we'll just deal with this. And I want to solve this for C, which is actually the speed of light. So to do that, I think I need to divide both sides by m. Whoops, because that's the opposite of multiply by m. So divide by m, and I get c squared equals e over m. And then square root both sides, I get square root of e over m. And that's your answer. This next one, PV equals nRT. This is this is called the ideal gas law. It talks about how pressure and volume and temperature are all related. N is, something known as the number of moles, and R is called Avogadro's number, which is a constant. And I actually used to know what R was as far as the value. I can't even remember what it is anymore, but it was a really, really large number, and I just can't even remember it anymore. But anyhow, I want to solve this for N. And you'll have to do this a lot in chemistry. So N is being multiplied by R and T. So I could do this in one step and divide it by both R and T at the same time. And then cancel, cancel. And N, the number of moles, is equal to PV over RT. By the way, those moles are moles as far as, they're not the moles that come out of the ground. They are moles of a substance that you have. A mole is a way of measuring stuff in chemistry. I always thought a mole was like a little thing that come out of the ground. Okay, so anyhow, let's do another one. A equals pi r squared. This is the area of a circle, and I want to solve for r. So I will divide both sides by pi. Pi is just a constant. Cancel, and I get r squared equals a over pi. And then I square root both sides, and I get r equals square root of a over pi. And I hope you found this helpful. Okay, here I want to solve for B1. Now this little 1 down here and this 2, these are called subscripts. And we use them if we have several variables that are kind of related to each other, and we don't want to use different letters. So B1 and B2 are somewhat related to each other. They're different variables, but in this problem, this is the area of a trapezoid, so these are both the bases of the trapezoid, and the little subscripts indicate that they're two different numbers, but they're related. Okay, so if I want to solve for B1, first thing I need to do is get rid of this 1/2 from the front of the parentheses. And I can do that by multiplying both sides by 2 over 1. So when I do that, I get 2a equals, and then the 1/2 and the 2 cancel, and I get h times b1 plus b2. Now, I still can't do anything with this b1. It'd be nice if I could get rid of that b2, but it's stuck in a grouping symbol. And grouping symbols are very powerful. You can't just rip them apart. So to get rid of the grouping symbol, I could start, if I didn't have anything out in front of the grouping symbol, I could just get rid of it. So I can start by getting rid of that h. So I divide everything by h, and that cancels, and now I have 2a over h equals, and because there's nothing out in front of the grouping symbol, there's no reason to have it anymore. So I just don't write it. And I have b1 plus b2. And then I am going to actually subtract b2 from both sides. So I have 2ah and then minus b2 on both sides. Almost ran out of room here. And then minus b2 equals, the b2's cancel there. I just get b1. Whoops. And I accidentally put b squared in all these places. I meant b2, not b squared. That's a completely different thing. So let me get rid of the little squareds here and put them in the right spot, because they are subscripts, not superscripts. Superscripts are exponents. Okay? So I have 2a over h minus b2 equals b1. And as ugly as this looks, you can't really do any more with it. Let's do another one. This is also the area of a trapezoid. The only difference is we want to solve for h this time. So again, my first step is to get rid of the 1/2 by multiplying both sides by 2. And I'm actually not going to write that step out again because you just know they cancel just like they did before. And I get this. Now, I want h by itself. Since h is being multiplied by both of these things, I can divide by both of these things. And if you want to keep them in parentheses, you can. You don't necessarily have to, because the division sign or the line here kind of acts as a grouping symbol. So those cancel as if they were one number. And I end up with h by itself on one side, and on the other side I have this 2a over b1 plus b2. And that's all we do there. So I hope you found this helpful, and maybe we can even do one more here. Let's do one where we have b minus a equals 4, and we want to solve for a. Well, I have to get rid of this positive b by subtracting b from both sides. That cancels, and I bring down the a. And then on the other side I have 4 minus b. And then I need to get rid of this negative, so I will multiply everything by -1. So boom, boom, boom. And my final answer is a equals -4 plus b. Or if you keep the negative in front of the 4, you could reverse the order and keep the positive b in front and write minus b at the end. So I hope you found that helpful, and I will talk to you again soon.